Hey guys, welcome back to another video. Today we're going to be discussing tension and all of its variants. So, tension is a branch of physics that is involved with force applied through strings or wires. And the idea of tension can be applied in a range of different systems, usually involving pulleys and friction. I'm going to just run you guys through some common cases in this video today. So let's look at the first question here. This is a basic example of tension. Tension can come in many forms. This one just discusses the main idea of tension without any pulleys or any friction. So the purpose of this question is to solve for T1 and T2. So how would you go about doing this? Well, you'd want to split your T1 and T2 into vectors. So T1 x, T1 y. Same here, T2 x, T2 y. Now, what would you need to do with these values? Well, using these values, you would want to find the 200 newtons of downwards force. Basically, what this means is the element of these two combined give a 200 downwards force, but there's no forces going to the side. That means the values of T1x and T2x cancel out because the only thing that's hanging down in a straight line is 200 newtons. So how would you go about solving this? Well, let's look at it. T1x, right? How would you get the x value of this? 26 degrees. This one right here is 45. The x value would need to be found out using the 26 degrees, right? And you would basically just say cos 26 degrees multiplied by T1, and this would be sine, that would also be cos, this time it's 45 multiplied by T2. Now, we have a value to find our x values, right? These two. How would we go about finding our T1 and T2 y values? Well, this one's a bit more complicated as we still have to work out with this 200. But what's interesting about these two lines here and this line here? Well, these two are going up. Don't you think? The tension is pushing it upwards and this is a downwards force. That means if you take out all of these upward forces and this downward force, you'd be left with a 0. So, we could tackle this in one way. We don't need to do two separate equations. We can just do it in one whole equation. Let's say that 200 is negative. That means these two top values must be positive because they're going up. The tension is pointing upwards. So, we would just have to label T1 and T2 as going up. Now, T1y would be sine 26 T1. And then, obviously, it's a plus because both of them are up. T2 sine 45 minus the one going down, which is 200, is equal to 0. Now we have formulated our two equations. We got the x's. We can formulate the x's into an equation, so let's just label this as y. Let's label this one as x. Basically, the x's are just, they cancel out and equal 0. How would you write that? Well, let's say the right side is positive, the left side is negative. And if we do so, it would just be cos 45 T2 minus T1 cos 26 is equal to 0. Now, if you're good at algebra, you can instantly identify what our next step would be. And that would be to solve using simultaneous equations. So, let's make x a subject, sorry, not x, let's make t1 or t2 the subject of one of these equations. I'll go with the x value, but any should work. So, if we made t1 the subject, it would just be t1 for this. T1 is equal to t2 cos 45 divided by cos 26, sorry. That is our value right there. Now, we sub this value into our big equation, right? So wherever there's a t1, we sub this into it. And that would just leave us with cos 45. And since it's taking the place of t1, it still needs to be multiplied by sine 26. But now it has a denominator of cos 26. The rest of the equation is still the same. 2t. Oh yeah, make sure you have a 2t at the start here because there's a 2t in this, and we're just subbing this into here. Right, so 2t sine 45 minus 200 is equal to 0. Whoa, I'm running out of page here. So, what would you do next? Well, this has become a very simple algebra question now. So all we'd have to do is to send 200 to the other side, and we would have to simplify this. So a calculator would be most appropriate for this situation. So let's just involve this calculator into the equation. So I'm just going to sub in all of my cos and sine values into my calculator, and it's going to give us a value for the left-hand side of our equation. Just type everything in. Plus sine 45. All right, so this is our value. Okay, now that's what our T2 value is. So that will be 1.05 T2. I will just create some more space for myself by moving the 200 to here. So what would that mean T2 would be? Well, we can just divide 200 by 1.05 to get our T2 value, which would be 200 divided by my previous answer, 190.12 newtons. Now, let's quickly solve for T1 as well. Now that we have the T2 value, T1 is very easy. We just sub in this value into this equation that we made before. So it would just be 190.12 multiplied by cos 45 divided by cos 26, which would give us a T1 value of, let me just type this quickly into my calculator, cos 45 cos 26, okay, 149.57 newtons. So that's that approach for the very easy common case that is usually seen with these tension problems. All right, so let's pick up where we left off and go straight to the inclined plane case. Now, the inclined plane case is a bit more interesting as it involves an inclined plane, and that has the property of sine mg. So let's just quickly decompose M1 and M2 here. The net force acting on M1 without the string, obviously, is sine 30 times mass, which is 2,500, times gravity, which would give us half times 2,500 times 9.8, 12,250. On the other hand, M2 would just give us a clean 4,000 times 9.8, 39,200. Now, immediately we're told to calculate the acceleration. The acceleration is simply just F net over m, which can be written as 39,200 minus 12,250 divided by the total mass, which is 2,500 plus 4,000. that adds to 6,500, which would equal to the acceleration of 39,200 minus 12,250, 6,500. 4.15 meters per second squared. Now, the next part that we would want to calculate is the tension. And since we have the acceleration, that's very, very easy for us. We know the system will accelerate towards the M2 side. So let's calculate the tension using the M1 side. We can calculate it either way, but I prefer doing the M1 side because I feel like it explains a bit more what's happening in the system. So we know that M1 is actually accelerating at 4.15 meters per second squared. How would we express that? 4.15 meters per second squared multiplied by the mass of 2,500 would give us the force, which is actually going to be our net force in our tension equation, because that is the true speed of acceleration and direction of acceleration that is going on this block. It's going up the slope at 4.15 meters per second. Now, how are we going to format the rest of the question? Well, that's pretty easy. We just have tension minus our weight force, which is actually pushing down. So the weight force, as described before, was 12,250. This means that the tension is simply 12,250 plus 10,375, 22,625 newtons is our final tension. Now that wasn't too bad. It just involved a bit of intuition and understanding to solve the question. But the next question, or the next side I should be saying, is it's a bit more complicated because it involves a bit of friction. And friction is always interesting in inclined plane questions because it kind of adds to the difficulty as you have another force acting on it, and it's a resistance force. So let's just do this question. And I'm not sure if this is enough space, to be honest, because these questions do take a bit of space. But once you get the idea of them, it's only a time thing. The rest of the question will be pretty straightforward for you to answer. So let's get right into this one. All right. We have a downwards force acting on M1 and a downwards force acting on M2. But we're also given that mu is equal to 0.21. So what does that mean? Well, let's address these two as in a system first. What is the total force acting on M2? Well, that is just 1,000 multiplied by 9.8. So 9,800 newtons. I think it's safe to say that it won't be accelerating towards M2's side, and instead it would go to M1's side. But just to make sure, let's quickly calculate M1. Now that's just 3,500 times sine 30, just as before. Obviously it differs when you have different degrees here, but just because we got sine 30 on the top and the bottom, it's a lot easier for us in this case. So sine 30 multiplied by 9.8. Sine 30 multiplied by 9.8. Now, that's 17,150. But we still have to account for friction. So friction is the force that opposes motion, which means that the force must oppose the motion at which it's traveling. So in this case, the force would be coming upwards. This would be the friction force, as it is opposing the motion of the M1 block scrolling downwards. Now, how would you calculate friction? Well, kinetic friction is just equal to force normal multiplied by the kinetic friction coefficient. So we just need to find the normal force and multiply it by the kinetic friction coefficient, which is given to us, which is 0.21. So, on an inclined plane, a simple way to calculate the normal force is to just do 3,200 multiplied by cos 30 multiplied by 9.8. This immediately gives us the answer to the normal force. And all we have to do after we get that normal force is to apply it. So that's just 29704.67. All we need to do is to multiply that by 0.21. So our frictional force would just be that answer multiplied by 0.21, which would give us 6,237.98 newtons of frictional force, which I will round off to 6,238 newtons. Okay, now, this is the part where we can calculate acceleration. So, we know that our total downwards force is 17,150. So we'll put that. So F net over mass, as always. So 17,150 will be our downwards force. But obviously, we need to take away the 1,000 kilogram force that's coming downwards. So that's just 9,800 here. And we must also take away the frictional forces of 6,238 newtons. What would that equal? 17,150, take away 9,800, take away 6,238. That would be a simple 1,112 newtons of force. Now, that divided by our mass of 3,500 plus 1,000, which is 4,500, it would give us our acceleration. So 1112 divided by 4,500. That just gives us an acceleration of 0.25 meters per second squared. Okay, that meters per second squared looks miserable, but can't do anything about that. Anyway, we can use this finally to calculate our tension. Now, which block would be better to calculate tension on? I feel like it would be M2, so I'm going to go with M2. But you can always just, try it out with M1 and see if you get the same answer as I do. So, let's see. On M2, we need to find the acceleration of the block, because that will be our net force. So, we can take our 0.25 and multiply it by the 1,000 kilogram mass. That will give us our 250 newtons of net force. Now, we obviously have our tension force, which we can acquire. And then we have to take away the 9,800 newtons of the downward force that was originally there. So, in the end, we will be left with a tension force of 9,800 plus 250, which would be 10,050 newtons of tension. So there you go. That's how you do these inclined plane problems. Sorry if that was a bit quick, but this video is already taking way too long. And the main thing that you have here is the working out, and I hope it makes a lot of sense. So I'll just go over it one more time for this one because it was a bit of a hard question. First, we started by identifying the raw force on both of our blocks. The raw force acting on M2 was obviously downwards, and that was 9,800 newtons. For M1, it was acting perpendicular, downwards again. So it was this vector, if you will. And that was 17,150. We then tried to calculate our friction. And that was simply done by calculating the normal force using this right here, and then multiplying that normal force by the coefficient of kinetic friction to get our frictional force right here. Then, to calculate acceleration, we took away 9,800 newtons and 6,238 newtons from our perpendicular weight force to get 1112. And then we divided that by the total weight to get our acceleration of 0.25 meters per second squared. Finally, we found the acceleration on the M2 block by multiplying our acceleration value by the weight of the block to find the net force acting on it. So that was 250 newtons. Then we made that equal the tension minus the previous, right? The previous net force on the block if there was no rope. And then we can easily find tension by moving 9,800 to the other side, as we did, to get our answer 10,050 newtons. And that's how you do it. All right, next example. All right, so we're finally at the extended case of tension. And this question is probably not going to be in your prelims or whichever exam you have. But it's an interesting case that would definitely help your understanding if you learn how to solve. So let's get right into it. Now, this question would most likely want you to find both tension and acceleration. So let's start off by finding the acceleration. For that, we need to find the net force. And for these, we have the 1,000 kilogram block. And all we need to do to find the value for that one is first we need to label these two sides. So let's quickly just get into that. Basic right angle trig. This would be 30. And the other one would be 40. So for the 1,000 kilogram block, the net force without a string would be a simple sine 30 multiplied by 9.8 multiplied by 1,000 kilograms. Similarly, for the 800 kilogram block, we would be dealing with a sine 40 multiplied by 9.8, once again multiplied by 800. So let's just quickly calculate those using a calculator. First one would just be a half multiplied by 9.8 multiplied by 1,000. 4,900 newtons, and the 800 case would just be sine 40 multiplied by 9.8 multiplied by 800, which would be 5,039.45 newtons. So that was very easy to calculate. And then to find acceleration, we just simply do this. So the net force would be such, and the mass would just be 1,800 kilograms. So what would that be? Well, that would just be 509.45, take away 4,900, divided by 1,800. Okay. That is simply 0.07 meters per second. 0.08, if you will. Meters per second squared. I'm just going to make sure that that is the right answer, because it doesn't look right. But I believe that should be the right answer. Okay. Now that we have that acceleration, all we need to do is to find the tension in the rope. Now, we have previously found tension for problems that are sort of similar, but this one, I believe, is obviously going to be a bit different to those, as it sort of involves two inclined planes. So that would complicate things a bit, but I don't think that it would be too hard. So let's just quickly get into it. So to calculate the tension, we first have to pick one block. In this case, let me go for the 1,000 kilogram block. The 1,000 kilogram block. So the acceleration on the 1,000 kilogram block should just be 1,000 multiplied by 0.8. Sorry, the net force, 0.08, by the way. That's just an 80 newtons. Now, the value of this would be tension minus the original downwards force. The original downwards force on the 1,000 kilogram block was 4,900 newtons. So what would tension be? Well, a simple rearrangement would give us the tension of 4,980 newtons. There you go. That wasn't too hard. So, yep, that's how you do tension. People think it's a lot more complicated than it really is. It's just about that intuition and those practice problems. So if you just keep practicing these kind of problems, you'll eventually understand the formula to solving these kind of questions. So you have an inclined plane, well, you know how to use sine and cos. There you go. You have friction, well, you just need to multiply the normal force, multiply by the friction, and sort of just add it into the problem. So, yeah, I hope that helped, and best of luck with all your studies.